Hello, everyone. We continue the Python review. Today we start with the sorting method. So we use the function sort. For example, for a given array, if we want to sort, then we call the function np.sort, and that will do in-place sorting. We can sort across rows and columns, okay? And we actually going to experience this in the next few cells, okay? Let's start with this example here. Here, we are generating a 1D array of size 6. There are 6 elements. The elements are randomly generated and the integer numbers between 0 and 9. So here, we generated the array, okay? Here we are printing out the indices of that array in a list. So we call the function toList that will create a list from the content of x1, from the numbers of x1. Then here we're calling the function np.sort and we're passing x1. So we're sorting the elements of x1 and then we cast it as a list and we print it out. So we just call the .sort that will do ascending sorting. So it's gonna start with the lowest number first, then the second lowest, and so on. We also can call argsort. Argsort will return the indices of the sorted elements. Their indices in the original list. So if the last element, for example, was the lowest one, the minimum, then its index will be the first index in the return of this function. Okay, so we're calling the argsort and we cast the output as a list. If we want to sort in a descending order, then we can do the sorting that will produce ascending order sorting, and then we flip the output, okay, the order of the output. So we start from the last element all the way to the first element. When we specify the step size here to be equal to -1, then we are flipping that. We're taking the last element to be the first and so on. So this will give us descending order sorting. As you can see here, these are the indices. This is the array, the random array we generated. Since 0 is the lowest one, it will become the first here in the sorted array. Then 3 is the second lowest one, and so on. So since the index of element 0 was index 1, it was the second element here. It has index 1. Now its index here. So 1, 0. So this is the sorted array, and these are the corresponding indices of those elements in the original array. So 0 has index 1 in the original array, 3 has index 2, and so on. And here, this is the sorted one. Now, if we read it from the back, this is the outcome of the last line. Okay, if we flip the order, this is what we get, which is descending sorting. Okay, now we come to 2D array. Okay, in 2D array, we can sort across rows and across columns. Okay, here it's saying sort row-wise. If you want to sort row-wise, okay, there was a discussion even between the instructors about is this considered as a row-wise or a column-wise when I go across rows. Okay, the bottom line is like when the axis is equal to 0, let me first generate this array. This is the generated array. When axis is equal to 0, then I'm taking every column and I go for that specific column and I sort the row elements. So I take the first column first thing. I take the first column, and since 2 is the lowest element, the minimum, okay, or the lowest element, then 2 will be the first, okay. Then after that, 5 is the second. So this column, looking at the first column, 2 will become the first, 5 will be in the middle, and 7 will be the last one. This is when we specify that we are sorting using the axis equal to 0. So the first axis, because now we have 2D array, there are two axes, okay? There is the rows and the columns, Okay, so x0 refers to the rows, okay, or the row axis, and axis equal to 1 refers to the columns or the column axis. So when we pass axis equal to 0, then we are taking this one column at a time and looking into the row content of that column. We are going across rows and we do sorting. So for the first column, now 2 will be the first element, then 5, then 7. For the second column, it will be 0, then 4, then 9. The third column will stay as is because it's already sorted. The fourth column will be 3. It will also be as is. So if we run this is what we get here. So the first one has been changed. The first and the second columns, both of them have been changed. Okay, they are sorted, and the other two columns, they are already as is because they have already been sorted. They are already sorted. So now if we want to do column, okay, as I said, now if we, yeah, you can, yeah, maybe this will confuse you like column wise, row wise, but just like if you want to sort the elements of every column, then use axis 0. If you want to sort the columns of each row, okay, let me say it again. If you want to sort the rows of every column, then use axis equal to 0. So then you're gonna go over every column and sort that the elements of that column, the rows. If you want to sort the columns or the elements of every row, then use axis equal to 1. This will take one row at a time, and it will sort the elements of that row. It will go horizontally. It will go across columns. The first one will go across rows. Go from row 1 to row 2 to row 3, and it will sort. That's the first one when axis is equal to 0. When axis is equal to 1, you will take one row at a time and you go across the columns. You go horizontal. Here you go horizontally when axis is equal to 1. Here you go vertically when axis is equal to 0. Here you take one column at a time and you sort the elements, and here you take one row at a time and you sort all the elements of that row. So then what do you expect to see here? Let's take the first row. Since 0 is the lowest value, then 0 will be the first element, then 2, then 3, 3. For the second one, we have 3, 4, 5, 5. The last one, we'll have 6, 7, 7, 9. Okay, so this is what we get here. 0, 2, 3, 3, 3, 4, 5, 5, 6, 7, 7, 9. Okay, now we come to another thing, which is copying an array. Okay, so if you use equal, okay, this is adding another reference to the same object, which means that if you do any change in the new array, that will also affect the original array. So here, look at this. Here we are generating a random 1D array. Here we are generating a new array, okay, called x2 copy, which is equal to x2. Okay, so we're using equal here. Okay, now we are adding a new reference to the same object. Okay, now if I change any element or set of elements in this new array, then the same change will be applicable to the original array. For example, here we created this array. Okay, now here what we did, we are extracting this slice, the first row and the second and third elements. When we go from 1 to 3, then we're considering the element with index 1 and element with index 2. So there are two elements here. So here we are extracting two elements from the first row. We're replacing their values with these elements. Since we are changing the value of two elements, we are passing two elements here inside these brackets. Okay, we are changing the value of these two, and then we are here printing out both the new array as well as x2, the original one. And as you can see here, both of them, the change was applicable to both of them. Okay, because this is not completely a new object. This is a reference to the same object. If I want to like create a new array from the content of this array, but then I want just to change the new array without affecting the original one, then I should call the function copy. Okay, this function is inside the object, so you call it x2.copy. Now this copy is created. This is another copy. Okay, it's not a reference to the same object. This is another copy, a new copy. Now we perform this change to the new one, okay, and we print out the new one as well as the original one. Then we see like the change applicable only to the new one. So the old one or the original one is as is, okay? So if you want to create a new object and you want to change the values there, play with the values of the new one without affecting the original one, then you need to call the function .copy. Now we come to reshaping, okay? Reshape method gives a new shape to an existing array without changing its data, okay? We can reshape 1D array of size 10 into, we can reshape it to a 2D array of size 5 by 2 or 2 by 5. We just want to maintain the total number of elements, okay? That has to be maintained, the size. So here there are 10 elements, then we can reshape it in the size of 5 by 2 or 2 by 5. Here, like 5 rows and 2 columns, or 2 rows and 5 columns. We cannot change the total number of elements, okay? We will see that. Let's here we are generating this array. Now this is, we reshape it as 5 by 2. So 5 times 2 is 10. So it's this, we are maintaining the size. Then we will have a successful reshaping. Here we have 5 rows and two columns for each row, okay? And now this was 1D array. Now we reshaped it into 2D array. As you can see, this is a 2D array. So we have 2 brackets here and here. So this is the first row, second row, and so on. We can also do it 2 by 5, okay? This is what we get. So 2 rows, this is the first row, and this is the second row. If I do, for example, 2 by 6, okay, I will get an error, okay? Because now we are not maintaining the size, okay? The total number of elements should not change, okay? If the original total number of elements, it has, if the original number is 10, then the size or the total number of elements in the reshaped version should be 10, okay? So yeah, we talked about this. Now, if I'm like I want a certain number of rows and I'm lazy to do the calculation and tell what's the corresponding number of columns such that the multiplication is equal to the total size, then I can just define the number of rows and pass -1 for the number of columns. Python will calculate it, okay? You cannot pass another number because it will see it as like you're changing the size or the total number of elements. But if you pass -1, Python will calculate it. So for this one, the number of rows 2, then I pass -1 here, then Python will know like we need to generate 5 columns here. It will generate 5 columns. The same thing here. The same thing here. So we pass -1 for the rows, 5 for the columns. Then this will generate, this will reshape it as 2, 5. 2 rows, 5 columns. This one -1 for the rows and 2 for the columns. Then this will be generated as the x1 will be shaped into 5 by 2, 5 rows and 2 columns. These are, yeah. Let's, for example, look at the last one here. We pass -1 for rows, 2 for columns. Then since it's 2 for columns and the total size is 10, then there will be 5 rows. These are the 5 rows here. We got 5 rows. First row, second row, and so on. Take, for example, the first one. So here we want to reshape x1 into 2, -1. Then the size is 10. Then this should be 5. Then we will have 2 rows and 5 columns here. We have 2 rows and 5 columns. Now we come to concatenating and splitting, okay? Concatenate means joining, okay? The function .concatenate is used to join 2 or more arrays of the same shape along a specified axis, okay? We will come to what we mean by this. Okay, let's take it one step at a time. So we can also perform vertical stacking and horizontal stacking. So vertical stacking, we stack things like in the like in rows, okay? And horizontal stacking, you stack things, you create like a fat array. Maybe this is, let's say that this is a tall array versus fat array. So if we stack vertically, then we are creating a tall array. If we are stacking horizontally, then we are creating a fat array. So we are adding more columns with the horizontal, and with the horizontal stacking, we are adding more columns. With the vertical stacking, we are adding more rows. Okay, let's look at this. So we start with concatenate. Here we are concatenating these three arrays. So we have generated these three arrays, X, Y, and Z, and we are concatenating them. They will be concatenated in the same order we specify here. So we pass X first, then Y, then Z, then they will be concatenated in that way, okay? And since these are, each one of them is 1D array, then they will produce another 1D array, okay? It's just combining all of this. This will be the first, second, and this is third, okay? This comes first, this is second, and this is third, okay? So this, so as it's mentioned here, it joins all 1D arrays along the axis 0, okay? Now axis 0 is the row, so in the same row, okay? It maintain the same dimension. Now, if we wanna concatenate them vertically, okay? Now, if we concatenate them vertically, then we are actually creating multiple rows here, okay? And in fact, we are moving from 1D because each one of them is 1D array. But when we do this vertical stacking, it's not a 1D array anymore. It's a 2D array. As you can see here, there are from these two brackets, you can tell, right? The outside brackets are for the array. Now this set of brackets for the first row, second row, and third row. So now we moved from 1D array to a 2D array, okay, by calling the function vertical stacking, and we are following this order. X is first, Y, and then Z, okay? And here, let me mention something here. Now this vertical stacking, if this has only two elements, what do you expect to see? We will get an error, okay? Now if I'm stacking vertically, then the number of columns has to be equal. If I'm stacking vertically, if I'm appending more rows, then the number of columns has to be equal. So if this has only 2 columns versus 3 columns for each one of them, then we will have an error. So the number of columns needs to be equal. Here, another vertical stacking here. If you look into this one, so the number of rows is not equal. X has only 1 row and Y has 2 rows. Okay, they are not equal. But since the number of columns is equal, okay, the number of columns is equal, we will still be able to stack them. Okay, so this is the first row, which is the array X. We put it first here, that's why it comes first here. Okay, and then this is the array Y. Well, these are the 2 other array rows, row 2 and row 3. Okay, so if we stack vertically, the number of columns has to be equal. Okay, now here we are stacking horizontally. If we stack horizontally, then the number of rows needs to be equal. Okay, if we're stacking horizontally, okay, then the number of rows needs to be equal. If we are stacking vertically, then the number of columns needs to be equal. So here, the number of columns for this one is not equal. Okay, this has 3 columns and this has only 1 column, but the number of rows are equal. This has 2 rows and this also has 2 rows. Okay, then we will be able to stack them vertically. Which one will come first? Z will come first. Okay, because we are passing Z first here. If I pass Y first, then Y will be first. So then the outcome will be, the first column will be 99, 99, the 2 elements of the first column, and the second column 9, 6, and so on, as we see here. Okay, this is the first column, which is Z, and then second, third, fourth. If I change the order here, then the first column will be 96. Okay, and 99 will be the last column. Okay, so now we come to splitting, and splitting is interesting here. So let's look at the splitting function. So here we are generating this array, okay, and we want to split it. Okay, so here if we pass our numbers inside the brackets, that means these are the indices where we want to cut. Okay, if I pass just a number like this, then that's how many cuts we need to have. Okay, equal size cuts. Okay, let's just follow the slides. We don't want to be ahead of the slides. Let's look at this now. We are passing two indices inside the brackets. Okay, we are passing two indices. Then if we pass two indices, then how many cuts we will have? How many subarrays we will produce? We will produce 3, right? So we have from the beginning all the way to the first cut, and from the first cut to the second cut, and from the second cut to the end. So we are generating 3 subarrays. Then we must have 3 variables here. If I have less or more variables, then I will have an error. Okay, I will get an error. So this number, the number of variables has to be equal to the number of cuts plus 1, right? So here we have 2 places where we cut, then we must have 3 variables here where we store the 3 cuts. Okay, now the first cut is at index 3. Okay, so this is index 0, 1, 2, 3. This is 3. 3 will not be included in the first subarray. So we cut at 3, then we include all the indices up to the one before, up to 2, okay, in this case. And 3 will be included in the second one. And in the second cut, we cut at 5. So 3 and 4 will be included in the second cut. And then the remaining ones will be in the last one, x3, okay? So now if we run this is what we get. Okay, this is the original array. This is the first subarray, second subarray, and third subarray. Now, if the index here is higher than the size, okay, then we will get an empty one here at the end. Okay. Okay, let's follow the slides because there's more about this here. Let's look at this one. Here it's a 2D array. So here, if we have 2D array, okay, we can, here, if we pass a number like this 2, this means this array along this axis 0, rows, I want to split it to 2 subarrays that are equal in size. They have the same number of rows because here we are considering axis 0. Okay, so then if I run this, then I will have every row in a separate subarray. Okay, this is the first row, and this is the second row. And the interesting thing, the dimensionality has not changed. This is 2D array. Okay, this, though it has only 1 row, it's still a 2D array. It's a 2D array that has only 1 row. Okay, the dimensionality has not changed. So here we said because we passed 2. Okay, now I can also do the same if I pass index 1 inside brackets. So this one, when I pass it inside brackets, that means I want in the along, like in this axis and the axis 0 along the rows, okay, cut at the row with index 1. So the row with index 1 will not be included in the first cut. So it will be in the second cut. Since there are only 2 rows here, then we will produce the same result. Okay. So if I pass 2, then you divide it into 2 equal arrays. Now what happens if this has 3 rows, okay, instead of 2? Now I want to cut it into 2 equal arrays, but actually this has 3 rows, okay? I cannot cut it into 2 equal arrays, then we will get an error, okay? We get an error. So let's remove this. So if we pass a number here, okay, then we are asking to cut that array into how many, like according to that number, if this is 2, then I want to cut this into 2 sub-arrays, okay, that are equal in size, okay, equal in the number of, depends on the axis we pass here. So axis 0, then I need 2 sub-arrays with the same number of rows, okay. If I pass this 5, then I need 5 arrays with the same number of rows for each one, okay. But if I pass indices here, index, for example, here, index has to be passed inside brackets, okay? If I pass inside brackets, then I want to cut at that specific index, at that row, okay? If I pass a number, then I need to produce that number of sub-arrays, equal size, equal number of rows arrays, because here it's in the axis 0, okay? So it's equal size arrays. It's the same thing. Okay, so what I was doing here. Okay, I forgot. Okay, here I'm cutting at, along columns. Look into this, I'm specifying 2 cuts. A cut at index 2 and a cut at index 3. If I look into the columns, this is the 0th column, first column, second column. So we're gonna cut here. So 3, 2, this column, 3 and 2, that we will be the beginning of the next sub-array. And in fact, it will be the beginning of that, it will be the only column in that array, because the next cut is at index 3. The next cut is at index 3, 0, 1, 2, 3. The next cut is at the index 3. So this 99, 1 will be in another sub-array. So I will have 3 sub-arrays. The first array will have the first 2 columns, okay? The second array will have the 3rd column, and the last array will have the 4th column, okay? This is the first array, okay? This is the first array. It has the first 2 columns. Then this is the second array. It has the 3rd column, and this is the 4th array that has the 4th column. Now we come to vectorized operations, okay? Operations that can be done on any array without using loops, okay? So for example, to make it simple. So here, if I have an array, okay, then if I add a scalar, subtract it, multiply by, Python will perform this operation, though the sizes are different. So here, this is an array and this is a scalar, okay? Python will replicate that scalar as many as the shape of this and perform the operation. So this is called vectorized operations. So Python will do it without, you don't need loop, okay? So for example, if you want to do this in C, then you need to create a loop and you need to iterate like loop across the elements of the array and add 5 to every one. Here in Python, you don't need to do that, okay? This is called vectorized operations. So you take the array, you can just add the scalar. Here we're adding 5, subtracting 5, just as simple as x plus 5, x minus 5, x times 5, you divide. So this will do, what will it do? It will add 5 to every element in x. This will subtract 5 from every element in x, and so on. This is multiply with 5, divide with 5, integer division with 5. Okay, so you can also perform other operations, not only add or subtract or multiply with some scalar. You can actually take the square of every element in x. So x squared, this x is an array. So what will happen here, the square of every element will be computed. Okay, you don't need to do a loop in order to square every element. Just pass it this way. X squared, that will square every element. And the same thing here, x remainder too. You can also perform multiple operations of this. For example, here we multiply x with 0.5. So every element in x will be multiplied by 0.5. Then we will add 1 to every element, and then we will take the negative of every element and square that. Okay, so let me run all of this. Okay, that's it. So universal functions. Okay, universal functions. Actually a vectorized wrapper. So it takes function like, for example, absolute here. Absolute takes a single number and returns the magnitude of that number, right? Yeah. So but actually here, if you pass an array, then Python will create a vectorized wrapper. Okay, so it will perform this operation, taking the absolute to every element in X. And in fact, I even tried like absolute to fix the original, like the Python built-in absolute, not the one inside the NP library, and it does the same thing actually. Okay, so if I have okay, let me define X here. Sorry, I forgot to. So let me take X. Okay, and then okay, so this is it. This is X, and this is the absolute of X. Even like the Python built-in absolute function does the same. Okay, so yeah, NP absolute X takes an array and it will return the absolute value of every element in that array. The same for square root, it will take the square root, min, max, and sum, and so on. Okay.